Okay, now today we shall discuss the concept of potential energy. Now, what is potential? Potential is nothing but capacity for action or for doing some work. Now, see, when the stretch bow is there, then if you stretch the string of the bow, okay, and you put the arrow properly, and if you release it, then what will happen? Arrow will be released with the speed. Okay, when a spring is compressed, okay, then if you are taking the compression out, okay, or if you take away that force which is compressing the spring, then it will be released with a tremendous speed. Okay, thus the body or any object which is having some capacity of doing work because of its position or configuration, then we can say it possesses the potential energy. Okay, now we consider a body of mass m. We take one object of mass m. Okay, then if you keep that object anywhere in the gravitational field, then the gravitational force will be always mg. Okay, so gravitational force near the earth will be mg. Now when you are taking that object from one place to the other, okay, at some height h, so you are taking the object somewhere, okay, at a certain height. So try to understand, say for example you have the object which is lying here, and you are taking this object here at certain height. This direction in which I am taking the object is taken to be the positive direction. This direction is taken to be positive direction. Say you are attaining the height h, then as you know that work done by the external force, try to understand mg force is in downward direction, then you are supposed to apply at least mg force in upward direction so that the object goes at certain height without any acceleration. Try to understand, without any acceleration you want to take this object from the lower position to a certain higher position. Now for that you are applying at least mg force. So work done is nothing but force that you are applying into displacement. Now here this is the work done by the external force, and that work done is stored in the form of potential energy. So this work done is stored in the gravitational potential energy, which is denoted by V. Okay, so the potential energy will be at height h will be mgh. Now here h is a variable. If you change the value of h, then this potential energy is definitely going to change. Now gravitational force if you want to find, then what should be done? Then force is equal to minus, try to understand, minus dv h by dh, or we can say force is a differentiation of potential energy with respect to height with negative sign. So if you take the differentiation of this mgh, okay, if you take the differentiation of this mgh, then h is the variable, mg is constant. So if you take the differentiation of this mgh, then we will have, say, d by dh, d by dh with negative sign mgh, and mg is constant quantity, so dh by dh will become 1. So the gravitational force which you are getting is minus mg. So gravitational force is in downward direction, it is the external force which is in upward direction which is doing the work against the gravitational force, and that is why this negative sign has come, because the gravitational force is in downward direction. Okay, always the gravitational force, as you know, that it is in downward direction. So the work done, if you want to find, then it is mgh. That work done is stored in the form of potential energy. Okay, and if you take the differentiation of this potential energy, negative differentiation of potential energy with respect to height, okay, then you will get the gravitational force to be minus mg, and minus sign shows that this force is in downward direction. Okay. Now we move further. When ball is released from this height h, then try to understand initial speed of this ball is 0. So initial velocity we can take its direction is downward in motion. Okay. So initial velocity is 0. So final velocity when it is about to hit the ground can be v square is equal to 2gh. So ball hits the ground. Okay, this is the speed v square is equal to 2gh. Okay. Now if you just multiply this by m on both the side, so it becomes 2mgh, and this 2 is taken in the denominator. Okay. So it can be easily concluded that 1 half mv square. Try to understand this way. Say v square is equal to 2gh. Okay, now just multiply by m. So what will happen? mv square is equal to 2mgh, and take this 2 in the denominator. So 1 half mv square is equal to mgh. So kinetic energy when it is about to hit the ground is equal to the potential energy, or we can say potential energy is getting converted into kinetic energy. Okay. So we can say that potential energy is converted into kinetic energy, and if you want to write this in a mathematical form, then mathematically potential energy Vx can be defined as Vx, that is potential energy at any distance x, or Vh, whatever, can be defined as if the force is f of x. Okay, then force at any distance x is equal to minus dv by dx. Okay, so it is negative differentiation of potential energy. Now just we have to multiply this dx here with fx, and if you want to find the work done by variable force, then you have to take the integration. So it has become f of x, that is force at distance x, dx. It begins from xi to xf, that is equal to minus dv integration minus dv, both the side integration is taken, it is vi to vf. So what is the basic thing here is just you are taking the integration and finding the total work done. Okay, say for example you have this f of x, that is force at any distance x, is equal to nothing but minus dv by dx. So just you multiply this dx with fx, so f of x dx is equal to minus dv, and to find the total work done we take the integration from initial point xi to final point xf. Then its potential energy initially is Vi, final potential energy is Vf. So by keeping this as dv, dv is having integration v, so it can be written as minus v into, rather limits are written, lower limit and upper limit, and then it is minus Vf minus Vi, and if you open the bracket then you will get Vi minus Vf, because negative will become positive, and that is shown here. Okay, integration is taken and the values are written here, Vi to Vf, and this is the formula for the work done, and it is nothing but change in its potential energy. So work done is nothing but change in the potential energy. Okay, so this is all about the potential energy. Okay, next time we shall discuss some of the things in the field of conservation of mechanical energy. Okay.